Go ahead. Now, do you want me to take written notes or?
Take written notes.
Okay, so make sure you get a good glottal stop there, like kitten, written.
Kitten, written.
There you go. Nicely done.
Can you see my screen?
Yes, I do. Hold on. I'm trying to pull up a document that I have for you. I'm going to put this in your podcast. No, I'm going to put it in your interview document. Okay. Just so I have a record of what we're doing. So you're recording this, so we can put this into script. That'll be fun. Maybe I should do. Hold on a second. Let me think. I guess I could only do it after the fact. Okay, I'm done thinking, and I am ready to listen and take notes. So you proceed when you want.
First, an overview of WhatsApp. Users are able to start group chats with multiple.
So no, wait a minute. So first, what, are you talking to somebody now?
Yes, I'm talking to you.
Are you talking to Monica?
I'm talking to. Wait. You are right. I am a little not clear. Unclear. So you are my interview. I am confirming with you the functional requirements we need to cover in this interview.
Okay. So then you can say something like, okay, so I'll get started.
I'll get started.
Blah, 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 blah.
Monica, WhatsApp is a powerful online message platform. Let me clarify with you.
Is a purple online message?
Is a powerful.
Oh,
powerful online
okay.
message. Let me clarify with you. Let me clarify what's requirements we need to cover in this interview. First, users should be able to start group chats with multiple participants up to 100. Users should be able to send and receive messages. Definitely. Users should be able to receive messages sent while they are not online. Up to 30 days. Users should be able to send and receive media in their messages. And we support up to 1 billion daily active user. And to fulfill this functional requirement, we need to make sure message delivery is low latency, less than 500 milliseconds. We guarantee that message delivery is guaranteed. And message is saved in the server no longer than 30 days, as the functional mentioned, no longer than 30 days. For the users who weren't online, who aren't online when the message is sent. And our system should be fault tolerant of a single component failure, which means we need to be able to recover ourselves if a single component fails. Okay, another one. We need to handle high throughput of semi-concurrent users. Concurrent. 1 billion. Daily 1 billion of daily active user. Next question. Next, we move on to core entities in this system. We mentioned there are users. Then clients, users could have multiple, more than one device. More than one devices. We have messages. Users could upload media. I will add chats here. And this one, chat is like a chat room or group where I can add or remove participants. For API or system interface, we would allow users to do two part of things. One, send. Another key component is receive. Under send user are able to create chat, and which include a name. User can specify a name for the chat. User can add participants. User would receive a response of chat ID to user. Once the create chat succeeds, user would receive a chat ID. A user could add or user could modify participants operation, add or remove participants. Once the operation succeeds, user would receive a response whether it is success or a failure. User would be able to upload media. I would send message first before, and chat the message, and whether user can upload media. User can upload media together with the message. Attachments. The user would receive a user would receive a response whether the message delivers succeed or fails. On the receive side, let me move it here to make it easier. Receive, when another user update the chats, the user would receive a notification. User would receive a notification. Okay, participants, updated participants. And when a user receive a message, it would acknowledge to the server, that I received. I should clarify. Receive means I send a acknowledge to the server that I received. I need to add something different from a regular web-based software. WhatsApp is a real-time message system. The difference between a HTTP-based website and a real-time messenger is WhatsApp give user updates in real time. For example, when a message sent back and forth, the user immediately have the correct mark, tell you it delivered and it is read. So the communication, if we rely on HTTP connection, which needs 3 handshake to build the connection. Once one request and one response finishes, it closes the connection. So the overhead to build one connection is expensive. So in a real-time application, instead of a HTTP connection, we need to use WebSocket connection, which keeps the connection open as long as the user is online. So I use WSS as the indicator that it is a TL, is an encrypted WebSocket connection. Design a simple system that allows users to create chats and aid participants. So So we have a simple client server architecture, but we have a web connection. We have a WebSocket connection behind L4 load balancer. Users, make it larger. Load balancer. Chat server. And chat server would write into a database. I choose DynamoDB in this case because DynamoDB fits the requirement of this design well, in the sense of it handles semi-structured data. DynamoDB. So when a user create chat with required participants, over a WebSocket connection, the chat server creates records within the DynamoDB. 2 records. One, it creates a chat with chat ID, participants, and it create another records for each participant. The reason for that is a lot of times we need to query for a certain participants. What are the chats this participant has? And also another common query is, for a given chat, what are the participants in this chat? Because of this requirement, we have the separate table where the chat ID as the partition key and participant ID as the sort key, and we would also have a global secondary index which reversed the sort key and partition key to help query to fulfill the different query. Update the design to allow users to send and receive messages. Send and receive messages. So we talked about create chat. Next, when user create a chat, add the participants, then he can start to send a message. Send message, and of course there must be the message content in the request. When first the user initiates a send message command, and the chat server creates a message record in the database. Message, it has what chat this message belongs to. We create a message ID and what's the content of the message. What's the contents of the message? And then to deliver to other participants, the chat server should maintain a hash map of participants' ID to web connection. The web server needs to maintain a hash map of current participant ID to its web connection. Whenever a message to be sent, the server look up the web connections of current online participants in this chat and deliver the message over the WebSocket. So I would write a double head arrow to indicate that it's send and receive. Get feedback. Extend the design to allow users to receive message later if their client is offline. When the user is offline, then the chat server doesn't have the hash map over its WebSocket connection. So we need to build an inbox for each participant in this chat. Inbox. And I misspoken. It's not one inbox over one chat. It's one inbox over one user. Within this inbox, it has multiple chats. So I have the chat ID, and I have a participant ID, which user this belongs to, and message ID. So the server first look up the connection for given participants. If there's no connection for that participant, the chat server would first write a record in the inbox. And when the user becomes online, first command, the client would initiate a update message operation to read the inbox content to the user. How we send, receive media attachments in the messages. So first, the chat server wouldn't handle the media at all because the media could be big and it's a waste of resource to handle by the chat server. Instead, we add a new command called get pre-signed URL. First, when user clicks upload, the client asks for a pre-signed URL, and the chat server asks a blob storage for a pre-signed URL and return to the user. And the user upload through the pre-signed URL. When the media is uploaded, the blob storage would return a media URL or media key. I would just call it URL. And the URL would send together as attachment in the send message command. And that's why the message table would have a attachment attachment field, which saves any media related. When another server or when other users receive this message, it would download the media through the URL. Download media. Get pre-signed URL. Okay, that's the workflow. To serve billions of simultaneous users, a single server wouldn't work. We need to horizontally scale servers. And when there's multiple servers, the hash map, where each server saves what connection it has, wouldn't help the whole system to communicate or deliver. Like server A wouldn't know which server that participant B connect to. To help that, we build a Redis pub serve to act as the routing layer among servers. So when a user gets online, the client first subscribe to the topic of this user ID. Subscribe to the user ID topic. And when a user sends a message, the chat server publishes to the first the chat server writes the message into the data table, into the database, and then the chat server checks which participants online, which participants has open topic, and then it publishes to all the open topic of those online users. And the servers which connect to that user handles the consumption of the message and delivery of the message. If users aren't online, and then we will go back to the previous path in which they would refresh the message whenever they are online. What do we do to handle multiple clients for a given user? To limit the complexity of our system, we can first give a limitation of how many clients that a given user can have, like 3, for example. A user can have 3 clients online simultaneously, and we would build a table for all the clients that a user have. Clients, user ID, device, client ID. Since there are multiple clients for a user, we need to deliver to every client rather than a single user. So the unit of a participant become a client rather than a single user. So right now the participant become a client ID, and then inbox, we build inbox for every client, not just for a given user. And the same as before in the Redis pub and sub model, the chat server need to build a connection with, subscribe to the topic of every client ID rather than a user ID. In this case, we deliver message to multiple device. It could be the user's iPad, desktop, iPhone. Yes.
Yeah, I have to switch rooms. Do you want me to do it real quick in 1 minute?
Yes. We finished all the questions. We finished all the questions.
Oh, we finished them? Ah, that's great.
Yeah.
So, oh, wow, so great timing. We're going to time out like in 1 minute, but I just want to say before I forget, I don't want to do just the negative stuff, you did a lot of great stuff, but your roughest section is the API route, by far.
Yeah.
right?
Yeah.
The rest of it was pretty good. So I'm gonna come back and I'll send you a